Okay, so there's a rational function. X squared minus 5x plus 6 over x squared plus 8x plus 7. So in general, it's going to make this process a lot easier for you if you start by just trying to factor everything that you can, that you see, numerator and denominator, because at some point you're going to need to use that information to get some of the stuff that we want. So I gave you two quadratics that are factorable here, and hopefully we can figure these out. And then once we do that, then we can keep going. So x squared minus 5x plus 6. What does that factor to? Mm-hmm. So x minus 3, x minus 2. Okay, and then that denominator, x squared plus 8x plus 7. Yes, you can. What is it? 7 and 1. X plus 1 and x plus 7. All right, so we got it in fully factored form here now. Let's go down our list, see if we can do each one of these things, okay? Sometimes we're going to want to look at this one that's in fully factored form. Sometimes we're going to want to come back to this one over here. Depending on what we're doing, it might be easier to use either one. So we'll kind of take a look at that too. So let's start with vertical asymptotes. Kind of abbreviate here a little bit. Okay, so vertical asymptotes. We said we want to look where g of x equals 0. G of x is the denominator. So which one do you think I want to look at, the original or the factored one? Actually, no. The factored one. Why do I want to look at the factored one for this? Each individual factor is going to give you one of those asymptotes, right? It's where that denominator is equal to 0. So if these two things multiplied together equals 0, where are my two vertical asymptotes at? -1, -7, right? Those are the two numbers that make that denominator 0. So yeah, having it factored is going to help. Okay, horizontal. So again, which form do you think is going to be more helpful in finding a horizontal asymptote? The original one, right? Because that's where we're taking a look at the degree of the numerator versus the degree of the denominator. And which of those two can I very easily see what the degree is? This one, the first one. Okay? So, what situation am I in here as far as the degree is concerned? They're the same. So if they're the same, what do? You divide those coefficients. And what are my coefficients? 1 and 1. So what should be my horizontal asymptote then? Y equals 1. Mm-hmm. Okay, so we got all of our asymptotes. Let's see, x-intercepts. So x-intercepts, we said that's where f of x equals 0. So where do I want to look for that? The factored one. Yes. F of x is the numerator. Okay, numerator. Where is that equal to 0? 3 and 2. Yep. So do you see how the vertical asymptotes and the x-intercepts you can just read right off of this thing once it's factored? Okay. That's why we did that. So x equals 3, x equals 2. All right, and then y-intercept. There's ever only one, so it's just the y-intercept. Which one do you think we want to go to? First one. Yeah. Okay. Remember, you're plugging in 0. Nice thing about that is, everywhere you plug in a 0, it turns it to 0, that whole term, right? So I can just go up to this original and say, all right, everywhere x is 0. Get rid of all of that. What do I have? 6 over 7, right? There you go. There's your y-intercept, 6/7. Okay, so that original is much easier for that. Just get rid of every term that has an x and what's left over. That'll be your y-intercept. Okay, so tomorrow what we would do with this then is we would draw these vertical asymptotes, draw this horizontal asymptote, put the x-intercepts in, put the y-intercept in, and then start to kind of piece together what this thing looks like all together. All right, for now, what I would like you to do, though, is let's graph this thing on our calculator and verify that all this stuff is right, that it looks the way we think it should. And be careful when you type these in that you use parentheses, otherwise it will not look right. So I'm looking at something kind of like that, right? X squared minus 5x plus 6 divided by x squared plus 8x plus 7. Both pieces have to be in parentheses. And if you have that in there correctly, then it's just a matter of making sure your window's the correct size so we can see everything. So if you look at all the intercepts and asymptotes we came up with, what's the biggest number you see? -7. So as long as we're out to 7 each direction, we should be able to see everything just fine. So maybe I'll just, to keep it a square window, we'll go -8, 8, -8, 8. See if we can see it all. And we might need to make it a little bigger just to get a better look at it, but in any event. All right, so probably want to make this window just a little bigger. So let's go, I think I'm going to go out to 15. Maybe that'll be a little easier to see it all. I might have to keep zooming out slightly, but yeah, this should be all right. All right, so this thing is kind of, what? How do I put them in? Yeah. Some calculators actually put them in, some don't, depending on what kind you're using. Actually, when the calculator does that, it's making a mistake. Because this calculator is trying to connect all the dots. And it plots a point like way up here, and it's like the furthest one up that it gets, and then the next one it plots is down here. So it tries to connect the dots together, and it ends up looking like a vertical line when it's actually not. So on yours, you have to kind of visualize a little bit where those would be, okay? But in any event, yeah, we should have a vertical asymptote at -7. So let's see, 1, 2, 3, 4, 5, 6, 7. And then we should also have another vertical asymptote at -1. And there's that one, okay? So we've got those both in there. We should have a horizontal asymptote at 1. Now on this one looks a little funky, but it is there. Remember, a horizontal asymptote is a number that the function approaches as it goes to infinity, okay? Now here's a really common mistake that a lot of students make about horizontal asymptotes. They assume that the function can never cross them. It is not true. A function can absolutely cross a horizontal asymptote. The key is, as the function goes to infinity, it approaches that number, though. So earlier on, your function might be going up and down and crossing that horizontal asymptote as many times as it pleases. But as you start to get larger, eventually it'll level off. And in this case, it's done that. And you see this little piece right here? It actually dips down, goes like down by 0, and then it starts to creep back up again. That's what this little line right here is. This is like a thick line. It's actually that function starting to creep back up. And what number do you suppose it's creeping back up to? 1, because that's your horizontal asymptote. But it crossed it, in fact, twice, down and then back up again. Well, no, I guess just once. It crossed it once. But in any event, yes, it can cross a horizontal asymptote. Just take a look as it goes out to infinity, what's going on. So the asymptotes are there. Intercepts. We said that we should have x-intercepts at what? 2 and 3. Now the window that we have right now, it's kind of hard to see. But remember I said it goes down and then it creeps back up again, right? So what it's actually doing is it's coming down right here, and then at 2, it dips just below, and then at 3, it starts to come back up again. So it's this tiny little boop, boop, and it comes back up. Okay? If you were to zoom in on that, you could see that a little bit better. In fact, I can probably do that real quick for you here. So it's supposed to be between 2 and 3. So I'm going to put a little box around it here so we can look at it. And let's make our window smaller. So let's have our Y's. Okay. I really zoomed in, but it happens. Okay. I really had to zoom in. But this is 2, this is 3. And it does actually come down and come back up again. So those x-intercepts, yep, those are right. It's in there. And then the y-intercept was supposed to be 6/7. So if I very quickly change my window again, 6/7 is supposed to be like almost 1. Okay, so take a look at that y-intercept. Is that right around 1, a little less? Yeah, it's there. Okay. So all of those key features that we calculated by hand are in the graph. Now this graph looks pretty crazy though, right? It's not like anything we've really studied before. And there's no one rational function that's like always looking the same as all of the rest of them. Okay, they all have asymptotes, they all have intercepts, but they can look all kinds of different crazy ways. Okay, so it's going to be a little bit of a challenge to put these things together for some of them. Some of them are pretty straightforward, some of them not. And we're going to talk tomorrow about some strategies we can use to try and figure out what exactly is happening like between the asymptotes, that sort of thing. But for today, I just want to make sure we can do the calculation side of things first. So we're going to focus on that the rest of the way today. So, all right, let's try one more. I'm going to let you guys have time to do this on your own. Okay? Get through this one, we'll be done. Okay? So, let's see. All right, so let's do that. 5x squared minus 5 over x plus 4.